All right, I'm going to take a look at the next section called 10.9, surface area of cones. So sticking with our theme, we're going to continue looking at 3D shapes and finding the surface area. Recall that a cone looks like this. Think of it like at the bottom of an ice cream cone. And the weird thing about a cone is when we're finding its surface area, which remember, of course, is the area along this as well as the area on the bottom, we are going to be turning it into a net. But the net of a cone is pretty weird looking. If I kind of slice along the edge here and I unravel it, I end up with a circle, that's the base, and I also end up with part of a circle. Oops. That is the rest of the cone that's kind of unrolled. And this is what my net kind of looks like. Let me try to do a little bit of a better one. Circle. And then this should be very circular. And then this part should be more straight. Kind of. It's kind of like a big Pac-Man attached with like a little tiny circle next to it. In this case, we're going to just need to find the area of these two pieces to add them up. And this piece is easy because we know how to find the area of a circle, but this piece is kind of tricky, and we're going to have to use another formula that we haven't talked about before in order to find what we need for that section. So let's take a look at an example and kind of see how this works. If I label these two, say we have this that is equal to 5 inches. And we also need this radius, or in this case we're going to call it the slant height, is going to be 11 inches. So again, this is our radius. And this is our slant height. That measurement that we've seen a couple of times. Our total area is going to be the area of the circle plus the area of the partial circle. Area of the circle is going to be easy because that's going to be pi r squared plus the area of the partial circle, which is going to be a little bit trickier. Well, the partial circle is actually a circle with just part of it missing. So we can use that knowledge to our advantage. And the formula that we're going to use is we're going to be looking at the ratio of the cone's slant height to its radius. So we're not going to use this as its radius in this case. We're actually going to use the base of our cylinder, the base of our cone, as the radius instead. And we're going to use the ratio of its slant height to its radius to tell us how tall this cone is. And what that looks like is this. The area of our partial circle, or in this case I can call it a sector, is going to be pi r squared times the ratio of the slant height to the radius, or the slant height to the radius. And this is going to tell us how tall the cone is, because with a smaller ratio, that means that the cone would actually be very short, and with a taller ratio, it would be very big. And that will tell us how much area is in that space. Now, what's interesting here is that I can actually simplify this formula out, because I can write it like this: pi times r times sh, my slant height, over r, because that's really what this is saying when I multiply by a fraction. And notice I can just cancel out my r's here, so my actual area of my sector is going to be pi times r times slant height, which is pretty weird that it kind of works out that way, but it does. So in this case, I'm going to return this back to my formula so that I can use it in here. And I'm going to write plus pi times r times slant height. And this is exactly the formula that I'm going to be using in order to craft and find the area of these shapes. It's tricky to find the two pieces this way, so I'm going to kind of skip that first step that we often do. And I'm just going to plug in the information that I have in order to get my answer. So this is going to be pi times radius. Remember, my radius is, in this case, 5, plus pi times, remember my radius is still 5 in this case, but my slant height is the 11. And that's kind of important to remember because this is the radius of the cone, not necessarily this shape over here, because the radius of this shape is 11, but in this case we're using it as a slant height. So we have pi, or we have 25 pi, 5 squared is 25, plus 5 times 11, that would be 55 pi. 25 and 55 is 80, which gives us 80 pi, and in this case, it would be inches squared. And that's how we're going to use this formula in order to get it. I'll do one more quick example, but if you feel like you understand, go ahead and go on, because this one is a little bit different than the ones that we've been looking at before. Okay, I'm going to do a new cone. In this case, our radius is 3 centimeters, and the slant height that we've got here is 9 centimeters. I'm just going to take that and put it right into my formula. I have my area of a cone is equal to pi r squared plus pi r slant height. So let's put it in. Pi times my radius of 3 squared plus pi times 3 times 9. It's going to give us what we need. We have pi, or we have 9 pi plus 9 times 3 is 27 pi. 9 and 27 is 36, I think. I hope. 36 pi. We're turning with our units. We have centimeters squared. And that's how we'll use it, and that's how we'll be able to calculate the surface area of our cones. Go ahead and good luck.